Hello everyone, welcome to today's video, and today we'll be solving a problem on similar triangles. This problem was taken from the Oplet Math Counts database. Triangle DEF is similar to triangle ABC. If DE is equal to 6, EF is equal to 12, and BC is equal to 18 units, what is the length of segment AB? For those of you who would like to solve the problem on your own, please pause the video in the next 5 seconds. Alright, we'll begin to solve the problem now. So, if you're solving any sort of geometry problem, what you want to do is you always want to draw it out, and you always want to write down what you already know. So, since the problem does give us drawings here, but we might want to draw them bigger so that it's easier to visualize. So let's say this is DEF, and let's say this is ABC. Of course, these are not to scale, so you shouldn't treat them as such. DE is equal to 6, we know that. EF is equal to 12, we also know that. And BC is equal to 18. Now, before we can start solving the problem, we need to know what similar triangles are. So, essentially, at the very basic level, similar triangles are triangles that have the same shape, but they're not the same size. What that means is, if you're increasing one side length of, say, DE by a certain multiple, like you multiplied a side of DE by 2 to get another triangle, let's say if we multiply by 2, we would get a side length of 12 here, because we have 6 times 2. We would also have to multiply EF by 2, and we know EF is 12, so 12 times 2 is 24. And DF as well would also be needed to multiply by the same proportion. So whatever DF's length is needs to be multiplied by 2. Thus, if we multiply every single side of the triangle by a certain number, and it's the same number for every single side length, then this triangle is going to be similar to this triangle. So likewise, if we look to the bottom right hand corner, we have two triangles here, and I expand it. These two triangles are similar simply because I made one of the triangles bigger, but I didn't change any of the proportions. I didn't squash it up or down, I just simply made the picture bigger. So that's essentially what being a similar triangle is going to mean. And another thing you might want to note is similar triangles, their corresponding sides are different proportions, but the angles of a similar triangle will always be the same. So even though ABC has a different side length here, all of the angles are going to be the same. Angle D is going to be the same as angle A. We would like to say congruent to angle A. And angle B would be congruent to angle E. And angle C would be congruent to angle F. They're always going to be congruent in similar triangles, and all of them will have to be congruent for them to be similar triangles. So what this means about similar triangles is we can set up proportions to compare them and to find side lengths of missing sides because we know they're in proportion. So if we think about it, we know that EF is 12 and BC is 18. And we know that the triangles are similar and EF corresponds to BC. In this drawing, it does tell you really easily that EF and BC are corresponding because they're the bottom part. But sometimes they do give you something just like triangle DEF is similar. I believe this is the word for similar to ABC. And they don't give you a drawing. So what you actually have to do is look at the order of how the letters are written in the triangle. So DE, the first two, are going to always be corresponded to the first two of this one. So DE and AB are going to be proportional, EF and BC are going to be proportional, and DF and AC are going to be proportional, always. So since we know that EF and BC are proportional, we know that whatever we multiply EF by to get BC is going to be the proportion of the whole triangle. So we can do this in a few ways. I'll show you the first one, and it's just to say EF times a certain number, x, is equal to BC. And EF is 12 times x is equal to 18. X is equal to 3 over 2, or 1.5. So we know that the proportion that we multiply triangle DEF to get BC by is 1.5. And since we know that if we go back to this original thing, DE is proportional to AB, and we want to find AB, if we just multiply DE by our proportion, then we will end up with AB. And since we have DE, we can multiply by 1.5 to find out that AB is equal to 9. So that's one way to do it. But another way to do it, if you'd like to learn more math, is to set up a ratio and a proportion. I will be erasing this and that. Okay, so what you have to do is say the ratio between EF and BC is going to be the same as the ratio between DE and AB. Why is that? Because we already know that BC is EF multiplied by a certain number, and DE is also AB multiplied by a certain number. So this proportion is always going to be the same. For example, if EF was 2 and you multiply, and that would mean BC is 4. And if DE is 5, AB would be 10. This proportion will always hold true if you realize that the same number is being multiplied, and you remember that EF and BC are proportional and DE and AB are proportional. You just need to make sure that whatever you think is proportional is the correct one, because if you mess it up, say you think EF is proportional to AB, then your problem will end up being wrong. So if we set up this proportion, we can say 12 over 18 is equal to 6 over AB. And we can solve this in two ways. Simplify this first, so that's 2/3 is equal to 6 over AB. We can cross multiply here. And so we get 2 times AB is equal to 18. AB is equal to 9. So those are the two ways you can get the answer. Your final answer would be AB is equal to 9. Just the biggest thing to remember when doing geometry problems is sketch it out, and if there's similar triangles, make sure you know what's proportional to what sides correspond to each other, because that is the most important thing. Either set up a proportion or do what we did right here, where we find out what the factor is that you multiplied by to get from EF to BC or whatnot. And you should be able to get all of these triangles, all of these answers for geometry problems like this one. Alright, thanks for watching this video.